Welcome all. So in this video lecture, this is the part 3 of discrete symmetries and Dirac equation. So today we are going to discuss, as we have previously discussed, the parity and the time translation. So today we are going to discuss the charge conjugation. Fine. Charge conjugation. Okay. So first thing we need to know is what is charge conjugation operation? What it does to different things. Okay. So the first thing we have is spatial coordinate. Does it do anything to spatial coordinate? No. Spatial coordinate remains invariant. Does it do anything to the time coordinate? No, time also remains as it is. So it's not a vector, sorry. And what happens? So what does it do? It just changes the charge. Suppose you have an electron to minus of that charge. Okay, the charge of antiparticle you can say. So it just reverses the sign of the charge. Okay. Now if we want to see the its action, first thing. Now let me tell you a thing beforehand. Okay, any charge particle shows its effect only in the only in the electromagnetic field. Okay, if there is a field, then only you can say it is negatively charged or positive charge. Okay, so if you want to see its operation, its function, so you need to take the Dirac equation under the electromagnetic field. Okay, so you know Dirac equation under EM field, that you know. How is it given? So the Dirac equation under EM field is nothing but this is your gamma mu d mu plus of kappa into I equals to 0. Now we do our daily routine, what we do always. So what we used to do is to separate the time and space part. So this is the space part and the second you have is time part. Okay, so this you got very pretty much good. It's looking good. Now what else we can do? We just now need to take the charge conjugation operation. So before that, let me tell you one thing. So you know gamma mu's are independent of charge. So they have independent of charge. So they have no charge in them, in their matrix elements. So they are basically independent of charge. That means they are also independent of charge conjugation. Okay, CC is a shorthand for charge conjugation. So now let me do it. So you will get gamma g charge conjugated, that is equal to gamma j. So you can remove that. dj charge conjugated plus of that was gamma 4 plus of gamma 4 d4 charge conjugated plus of kappa you know is m naught c by h. So that is also independent of charge times of psi c charge conjugated. So if you want to know the Dirac equation under the charge conjugation operation, so you need to know these things. First, this one dj charge conjugated, d4 charge conjugated, and psi charge conjugated. So for psi charge conjugated, you have nothing. You can assume a simple form. So psi charge conjugated you can take as lambda c, some lambda c times psi star. Why star? Because it is an anti charge conjugation is an anti-linear operation. Okay, so now lambda c we don't know. Lambda c we will calculate later. What is it? Till now we can just take this form. So now replace this in this equation. You will have gamma j dj c plus of gamma 4 d4 c plus of kappa times lambda c psi star equals to 0. Fine. Now let's get back to our job. What is our job? Our job is to first evaluate dj charge conjugated. What is this? d4 charge conjugated. What is this? Okay, so these are the two tasks. So let's proceed further. The first task we have for today is djc. So let's calculate this. Now before this, you should know what is d4, what is dj. So dj, as you know, is delta j minus of ie by h cross c into aj. So you know what is your aj? Aj is your external field. Aj is due to the external field. Okay, so it corresponds to the external field. It is a magnetic vector potential, basically external field. Fine. So external field means that will be independent of that charge conjugation operation. Okay, so the charge conjugation operation in no way going to make any difference to it. So that this will remain as it is. Similarly, delta j you know is nothing but j runs from 1 to 3. Yeah, this is basically delta by delta x, or you can say delta by delta x1, which is in turn is equals to delta by delta x as we write. or delta by delta x2 is nothing but delta by delta y, and similarly delta by delta x3 is nothing but delta by delta z. So none of these is containing any charge term. So you can say del j charge conjugated simply is equals to delta of j. Okay, that will also remain invariant. So let me remove this. Okay, you have got my point. Now if you complex conjugate the dj thing, you will get delta j not complex conjugated but charge conjugated. So see here you have a e. You see here you have a e. So what will happen? So you will get plus, here you will get a plus sign. So we get plus of IE divided by H cross C into AJ charge conjugated. In the next line we get delta J, as it has no effect, plus of IE by H cross C. This has also no effect. This thing also have no effect. So you will have AJ. Now if you have a careful look, okay, if you have a careful look, you can see that this equation, which is the below equation, this is nothing but just the charge conjugation of this equation. See here you have minus e and here you have plus I. Okay, so what happens when plus I gets converted to the minus I, that means this is the complex conjugated of that thing. So you can write it as dj complex conjugated. Fine. So what do you get? You get dj charge conjugated is equals to dj complex conjugated. So this is our first result for today. Now we need to calculate what is our d4 charge conjugated. Okay, so for that we need to write first the d4. So d4 is delta 4 minus of IE by H cross C A4. Now let's see what is our del 4. Del 4 is del by del x4, or you can say del by del ICT. Does it contain any term regarding charge? No, it does not contain. So del 4 will remain as it is. Okay, so no effect. And A4 will also have no effect. So that will also remain as it is. So when we now apply charge conjugation, we have this minus e changes to plus e, and A4 charge conjugated. In the next line we further solve it, we get delta 4 plus of IE by H cross C A4. This is our D4 CT. Fine. So now, as you know, previously we got a relation between the complex conjugated thing and the charge conjugated thing. So can we do something like that here too? Let me check for you. Okay, can you write directly as the complex conjugated of this? No. You see why? Because there is a delta 4. So if you complex conjugate, you will get a minus sign here too. Okay, so we will see how can we write this. So you have d4 as delta 4 minus of IE by H cross C A4. Fine. So now what happens when you complex conjugate this thing? You have to see this has a I. Okay, this is the iota in it. So you can, when you complex conjugate it, you will get minus of this thing. Similarly, this is minus I, so this will become plus of IE by H cross C. And A4, as you know, this has also a item. A4 is what you have I pi. A4 star is basically minus of A4. Fine. So let's do it. So D4 star, if you calculate it, you will get delta 4 star will be minus delta 4. Let me show you how. Delta 4 means, let me write it here. Basically, let me use a different color. Basically, delta 4 is equals to del by del x4. Fine. So del x4 means del ICT. Now what happens when you complex conjugate it? When you complex conjugate delta 4 star, or you can say you complex conjugate these things, what do you have? You have minus of del by del ICT. Okay, why? Because the I goes to minus I. Okay, so what is this? If the bracket quantity is nothing but your delta 4, so you get minus of delta 4. You get delta 4 star is equals to minus of delta 4. Okay, so that's why I did here minus delta 4. With this you have IE by H cross C. Now see A4 star, as I told you, A4 is minus I phi, not A4 is I phi, and A4 complex conjugated will be what? It will be minus of I4 complex conjugated will be minus of I phi, or you can write it as minus of A4. Fine. So let me substitute this thing also. So you will have delta 4 minus of a4. Fine. Now if you take the minus common, you will get delta 4 star is equal to minus of delta 4 plus of IE by h cross c times of a4. Fine. Okay. So what's next? So this thing you see is nothing but this, यानी कि d4 चार्ज कॉन्जुगेटेड है ये चीज. तो d4 स्टार को आप लिख सकते हो माइनस ऑफ d4 चार्ज कॉन्जुगेटेड, और आप लिख सकते हो d4 चार्ज कॉन्जुगेटेड इज टू माइनस ऑफ d4 स्टार. ठीक है. तो ये हमारा सेकंड रिजल्ट ऑफ द डे है, विच इज d4 चार्ज कॉन्जुगेटेड इक्वल टू होता है माइनस ऑफ d4 कॉम्प्लेक्स कॉन्जुगेटेड. ठीक है. तो अब हमको अपने दोनों रिजल्ट मिल गए. अब इन दोनों रिजल्ट को हम सब्स्टिट्यूट करते हैं जो हमारी डिराक इक्वेशन अंडर चार्ज कॉन्जुगेशन थी, जो कि थी गामा जे dj चार्ज कॉन्जुगेटेड प्लस ऑफ गामा 4 d4 चार्ज कॉन्जुगेटेड प्लस ऑफ कापा साई पे चार्ज कॉन्जुगेशन लगाया था तो आप हमको मिला था lambda c times psi equals to 0. Okay, so now let me substitute the value. Gamma j dj c, you know, is nothing but dj complex conjugated. Similarly, this thing gamma 4 d4 complex conjugated is what? It is minus of d4 complex conjugated. We just got the result. Okay, you see here it is plus of kappa as it is, and with this you have lambda c times psi is equals to 0. Fine. So इससे आगे जब हम इसे सॉल्व करेंगे तो हमें क्या मिलेगा? गामा जे लैम्डा सी से अंदर मल्टीप्लाई कर देते हैं. गामा जे लैम्डा सी डी जे स्टार आपको मिलेगा माइनस ऑफ गामा 4 लैम्डा सी डी 4 स्टार प्लस ऑफ कापा लैम्डा सी इंटू साई. ये चीज़ आपको मिलेगी इक्वल टू 0. ठीक है. अब एक और ऑपरेशन परफॉर्म कर सकते हैं हम, लैम्डा सी इनवर्स से मल्टीप्लाई कर सकते हैं. ठीक है. लैम्डा सी इनवर्स इंटू गामा जे इंटू लैम्डा सी डी जे स्टार, साथ में आपको मिलेगा माइनस ऑफ lambda c inverse into gamma 4 to lambda c into d4 star plus of the lambda c inverse and lambda c will be equals to 1, so you will simply have plus of kappa into I equals to 0. Fine. Now let's do one more thing. So हमारे पास जो होती है आपकी डिराक इक्वेशन, आपको पता है क्या होती है. ठीक है. तो डिराक इक्वेशन आपके पास होती है, मैं यहाँ से डिराक इक्वेशन लिख रहा हूँ, डी जे गामा जे डी जे प्लस ऑफ गामा 4 डी 4 plus of kappa into psi equals to 0. So simply do one thing, just take the complex conjugate of this equation. So you will have gamma j star dj star plus of gamma 4 star d4 star plus of kappa into psi star. Okay, psi star, all this equals to 0. So now simply compare the coefficient of dj stars in these two equations and d4 star. Okay, so comparing coefficient of these two equations, let me change the color of these two equations for you. Let me turn it to yellow and also this one to yellow. So now when you compare the coefficients of in these two equations of dj star and d4 star, what do you get? The first thing is you have is dj star. So let's compare the coefficient of dj star. You will see here you have this thing which is equals to lambda c inverse gamma j lambda c is equals to gamma j star, and then you have for d4 the coefficient for d4 is minus of lambda c inverse gamma 4 lambda c is equals to gamma 4 star. ठीक है. What is gamma j star and gamma 4 star here? See, for this you need to know the fact that what you have is gamma 1 and gamma 3 are your complex matrices. Okay, so they are complex matrices, so that means you have gamma 1 complex conjugated is equals to minus gamma 1 and gamma 3 complex conjugated is equals to minus of gamma 3. And for gamma 2 and gamma 4, what do you have? These are just real matrices, they don't have any iota in them. So for them you have gamma 2 star is equals to gamma 2 and gamma 4 star is equals to gamma 4 simply. Okay, fine. So if you substitute this equation in this, what do you have? So let me just put it aside. So see, what do you have? So you will have for gamma 1, let's see for gamma 1 what do you have? You will have gamma c inverse gamma 1 lambda c equals to gamma 1 star. As I told you, gamma 1 star is minus of gamma 1 c here. Okay, so you can also write this equation as, let me use a different color. So if you pre-multiply both side by lambda c here also, and this side also you will multiply by gamma lambda c, what do you get? That will become lambda c into lambda c inverse in the left hand side become 1. So you will have in the left side gamma 1 lambda c equals to, similarly in the right hand side you will multiply with lambda c, so you will have minus lambda c into gamma 1. Fine. Or you can write it as gamma 1 lambda c plus of lambda c gamma 1 is equals to 0. That means what? That means lambda c anti-commute with gamma 1, anti-commute. Okay, so now let's see for gamma 2, what do we have? We have lambda c inverse gamma 2 lambda c is equals to, lambda 2 is also नहीं, lambda 2 is real है, lambda 2 real है. Okay, so lambda 2 real है तो आपको क्या मिलेगा इसके लिए? इसकी जगह पे आपको मिलेगा नॉट lambda 2 बट gamma 2 रियल है तो आपको यहाँ पे क्या मिलेगा? gamma 2. ठीक है, ये यहाँ से आप देख सकते हैं इस चीज़ को. सिमिलरली lambda c इनवर्स lambda c से मल्टीप्लाई करेंगे बोथ साइड तो आपको क्या मिलेगा? आपको मिलेगा gamma 2 lambda c इक्वल्स टू, so after that you have gamma 2 lambda c is equals to your lambda c gamma 2. Okay, so you can also write this as gamma 2 lambda c minus of lambda c gamma 2. Okay, so you can see simply gamma 2 commutes with lambda c. Okay, so it is commuting, gamma 2 is commuting with lambda 2. Now for gamma 3 you have lambda c inverse gamma 3 lambda c will be equals to what? Minus of gamma 3, as it is, see, gamma 3 star, I just replace that with minus of gamma 3. So you will have, you can simply write this. Okay, you know, first you will multiply both sides with lambda c inverse, you will have gamma 3 lambda c, here you will have lambda c gamma 3, so that will anti-commute, so you will get gamma 3 lambda c plus of lambda c gamma 3, so that is anti-commute also here, anti-commute. Similarly with gamma 4 you can say you have minus, see, for gamma 4 you have a minus sign in left hand side too. When you compare the coefficient you got here a minus sign too, so you have minus lambda c inverse gamma 4 lambda c is equals to, in this side you have gamma 4. Why this is a, because this is a real matrices, so you will have, if you multiply lambda c by both sides you will get minus of gamma 4 lambda c equals to lambda c times gamma 4, or you can write it as, ignore this thing for a while, or we will have your lambda c gamma 4 plus of gamma 4 lambda c equals to 0. This is also anti-commuting with this one. Okay, so this is the lambda c is commuting only with this one, that is gamma 2, and it is anti-commuting with all the other three matrices. Okay, so what does that mean? You know, a matrix commute with itself only. Okay, and it anti-commutes with all the other matrices. So that means you are what you have the unknown equation, which is your lambda c, that is just equals to gamma 2. How we concluded that? Because this matrix commute only with the gamma 2. Okay, so now is your lambda c came out to be equals to gamma 2. What is gamma 2? Gamma 2, you know, gamma 2 is your, तो गामा 2 आपका इक्वल होता है 0 0 0 minus 1 0 0 1 0 0 0 0 1 0 0 minus 1 0 0 0. So ये आपका गामा 2 होता है. ठीक है, अब as always what we used to do is to see its action on the particle. Okay, now let's take a particle of positive energy, spin up, and positive momentum. Okay, so how you represent this particle, you know, as this is nothing but your psi 1. Okay, this is represented by your psi 1, and this this happens to be equal to u1p into exponential of I by h cross p vector dot r vector minus of et. Fine. So this is your particle. Okay, now you know what happens when you apply charge conjugation on this equation. You simply get lambda c times of this psi 1 complex conjugated. Psi 1 complex conjugated means this thing complex conjugated. Okay, so before that, okay, let's do that first. So lambda c remain as it. Lambda c, you know, is equals to gamma 2. Let me replace that value. That is gamma 2. And for psi 1 star, you will have u1p into exponential of I by h cross p dot r minus of et, this whole thing complex conjugated. Okay, fine. And now you can replace the value of gamma 2 simply. So what is gamma 2 equals to? I just told you. Gamma 2 is equals to 0, 0, 0. See here, 0, 0, 0, minus 1, 0, 0, 1, 0, 0, 1, 0, 0, minus 1, 0, 0, 0. Okay, it's nothing but Dirac's gamma matrices. This is second Dirac gamma matrices. Okay, along with that you will have u1p complex conjugated. Okay, this complex conjugated will act on u1. So u1p we discussed in the parity operator case in detail. That was equals to your u1p was equals to 1, 0, cp by m naught c cp by e plus of m naught c square, and at the end 0. This p was pz, momentum along z direction, and px and py was 0. Okay, this is with that consideration. If you need to learn that, you can watch my video on the parity operator. There I have discussed before what you have u1p and what happens when you take the particle traveling only along the z direction. Okay, so this thing will be complex conjugated, and along with this, if you complex conjugate this minus I will get replaced with this plus I will get replaced with the minus I. So you will have exponential of minus I by h cross p dot r minus of et. फाइन, तो यहाँ तक ठीक हो गया आपका. अब देखो इसका कॉम्प्लेक्स कॉन्जुगेट क्या होगा. इसका कॉम्प्लेक्स कॉन्जुगेट ये होगा, क्योंकि इसमें कोई आयोटा तो है नहीं, तो मैं कॉम्प्लेक्स कॉन्जुगेट को सिंपली रिमूव कर देता हूँ. ठीक है, अब इन दो मैट्रिक्स को आपको मल्टीप्लाई करना है सिंपल. सो फर्स्ट रो इंटू फर्स्ट कॉलम करेंगे तो आपको क्या मिलेगा. फर्स्ट रो इंटू फर्स्ट कॉलम करेंगे तो आपको मिलेगा बेसिकली 0. ओके, अगेन फिर सेकंड रो को आप सेकंड कॉलम से मल्टीप्लाई करेंगे तो क्या मिलेगा. जैसा कि आप देख सकते हैं, आपको मिलेगा cp बाय एप्सिलॉन प्लस एम नॉट स्क्वायर, दैट इज एनर्जी एप्सिलॉन. सो थर्ड रो को करेंगे तो क्या मिलेगा आपको. थर्ड रो को करेंगे तो आपको मिलेगा 0, एंड फोर्थ रो को आप करेंगे तो आपको मिलेगा माइनस ऑफ 1. ओके, अलॉन्ग विद दैट यू विल हैव एक्सपोनेंशियल ऑफ, माइनस को मैं अंदर मल्टीप्लाई कर सकता हूँ तो आपको मिलेगा आई बाई एच क्रॉस, माइनस को मैंने अंदर मल्टीप्लाई किया तो आपको मिला माइनस ऑफ पी डॉटेड विथ आर प्लस ऑफ ई टी. ओके, दिस इज व्हाट यू गेट. तो यहाँ पर अगर आप माइनस कॉमन ले लो तो आपको क्या मिलेगा. आपको मिलेगा 0, अंदर से नेगेटिव का हो जाएगा तो मैं इसको इस तरीके से लिख सकता हूँ, एप्सिलॉन प्लस एम नॉट सी स्क्वायर हो जाएगा 0, ये आपको जाएगा +1. ओके, एक्सपोनेंशियल ऑफ आई बाई एच क्रॉस माइनस पी डॉट आर माइनस ऑफ ई टी. अब ये जो चीज़ आपकी है कुछ नहीं है, पर ये u4 है. ओके, ये u4 है, ये आपके स्पिन डाउन वाली पार्टिकल की स्टेट है, वो भी नेगेटिव मोमेंटम के साथ. ठीक, so what does that mean. It means when you apply the charge conjugation operation, what happens beforehand we were taken, हमने कौन सा पार्टिकल लिया था. हमने लिया था पॉजिटिव एनर्जी स्पिन अप और पॉजिटिव मोमेंटम पार्टिकल हमने लिया था. इस पर हमने चार्ज कॉन्जुगेशन ऑपरेट किया तो क्या हुआ हमारा. देखो ये जो होता है ना, ये करस्पॉन्ड करता है U4। ये जो मैट्रिक्स दिख रही है आपको, अगर रिमेंबर हो तो डिराक के क्वेश्चन में जब हम पढ़ते थे, तो ये करस्पॉन्ड करती है आपके स्पिन डाउन पार्टिकल को। ओके, स्पिन डाउन पार्टिकल को विद, और यहाँ पर दिख रहा है आपको मोमेंटम क्या है इसका, नेगेटिव। तो मोमेंटम क्या हो गया, नेगेटिव। और एनर्जी कौन से पार्टिकल को करस्पॉन्ड करता है, ये देखो ये यहाँ पे माइनस साइन आ रहा है, नो यहाँ पे प्लस साइन आ रहा है, सॉरी प्लस था ना, देखो यहाँ पे प्लस था, तो प्लस ये है, इसका मतलब किसके करस्पॉन्ड कर रहा है, इसका मतलब है कि नेगेटिव एनर्जी को करस्पॉन्ड कर रहा है, ठीक है। तो कुछ दिख रहा है आपको, तो ये क्या है, बेसिकली एंटी पार्टिकल बन गया, इसका एंटी पार्टिकल बन गया। तो चार्ज कॉन्जुगेशन आप जब अप्लाई करते हैं तो आपको क्या मिल जाता है, आपको एंटी पार्टिकल ऑपरेशन मिल जाता है, ठीक है। सो दैट्स ऑल फॉर टुडे, थैंक यू वेरी मच फॉर वॉचिंग।